I'm going to talk about containers and containerizing your applications, and also containerizing your database and some different techniques for doing so. The session title isn't really containerize something, but when I gave this presentation last time, I realized I made a typo and I couldn't remember the name of the session, so it became containerize something. It's all good. When I started working in IT, which is a while ago, these were things we looked at. We looked at servers, we looked at the CPU speed of the server, we looked at how much internal RAM we had out of the box and how much we could fit into it, etc. And then we had these Dell PowerEdge boxes. I remember we had a Dell server which was probably 8U high, standing on the floor. It had an extra like socket to the bottom of it to avoid flooding and so on. And that was the everyday life basically of me as an accidental DBA to work with the hardware as well. So when we're deploying a new system in roughly year 2000, we would order hardware and we would sometimes assemble the hardware because we would get the disks in one box and the CPU in one box, and we would assemble the server, and then we would configure the network, which meant actually changing cabling to enable networking for this box. And we would configure the operating system on the box, and we would install SQL, and then finally we could deploy a database to it. And some of the things I did on more or less a daily basis was to check if disks were near capacity. And if they were, we would order new disks, hardware, I mean, and maybe new controllers, and maybe even we had to build new RAID arrays because the controller we were using was full, so we needed a new one. And we would look at there's this little light. If it's green, it's okay, and if it's yellow, there's a problem with the disk, and if it's red, that means the disk itself is actually defunct and you have to replace it. So we had to replace faulty disks. And when we were at maxing out on CPU, we would order a new CPU and put it into the server itself. And database changes, when we deployed them, that meant we didn't have a pipeline to deploy anything. We, as a DBA or even as the developers, we would log into production and execute some DDL scripts and hope that it didn't cost too much blocking. So since then, a thing or two has changed. Let me change my picture so you can actually see the presentation. So I've been through a couple of revolutions, and I'm going to just quickly go over them and then go into what I call the third revolution since I started working with IT. First, a little bit about me. My name is Magnus. You have my contact details. It used to say Twitter. I never changed it to X. Instead, I quit using Twitter and I use Blue Sky instead. But my nickname is basically the same everywhere. It's Transmocopter, and that's the name of the company where I am the only employee. I work as an independent SQL Server consultant, which is mostly on-premise, but I have done a couple of cloud migrations. But what I really know well is probably the database engine. And then what's been added on top of it, instead of replacing faulty disks, I worked a lot with automation. So a lot of PowerShell and a lot of containers, mostly for my own development and test. I have a blog that's not really much to brag about. I rarely write on it. I use it as a placeholder or as a reminder. When I stumble upon something, I write about it, and the next time I stumble upon it, I realize, I wrote something about it. So I go back to my notes and see what I said back then. I run a weekly event called SQL Friday. SQLfriday.net is the website, and the only interesting on that website is a link to the meetup group where you can sign up, and then you will get invites to Friday noons Central European time, there's a new speaker every week, and they will present some interesting SQL Server related topic. And on Friday, the upcoming Friday, we will have the legendary Klaus Achenbrenner coming to SQL Friday. So that's the shameless plug. If you want to see some of my videos or some of the recordings from SQL Friday, you can go to the YouTube channel on screen right now. All right. My first revolution that I was a part of. Revolution sounds a bit maybe violent, but I mean a drastic change. The first drastic change I saw in IT that I was a part of was the use of a storage area network. Instead of having disk cabinets or disks even inside the servers themselves, we would connect through a fiber channel to a storage area network, which is a larger box with more disks, and we could log into the storage area network and we could create a loon, and we would give that to a server, and it was much easier to maintain storage for databases and for other things. So that's the first kind of revolution, and the first, I'm going to say, virtualization of disks. Instead of having your own hardware in the server, you would get a piece of disk. It didn't have to be a whole array. It was a slice of that disk would be handed to the server, and life became a lot easier. The second revolution was virtualization, where we started using virtual machines instead of using physical servers for everything. And we were able to build large clusters, and we would use these clusters to create virtual machines. And even in the cases where we had a system that needed so much power that it had its own server, we started virtualizing, creating a hypervisor and create just one guest virtual machine on that hypervisor, because life became so much easier when we had a server crash. If you have a lot of servers in a data center, you know that there will be hardware issues. We could just live provision or do a live motion of that virtual machine to a new hardware, and it would be all seamless, at least in theory, but it became a lot easier to work with. And it became a lot faster to install a new system because you didn't have to order new hardware. There was always some space left in a hypervisor, and you could start small and see, is this business growing? Is this application growing? What are the demands? You could start with 2 CPUs, and then when it needed 4, you just added 2 more, etc., etc. You can even have like balancing the loads. You would move CPU power and RAM over to one virtual machine when it was doing batch processing in the night, and then you would move it back to the other machines when you did normal operations in the daytime. So much more flexibility. And the third revolution that I want to mention is containers. And that's the kind of topic for today as well. So with containers, we take things one step further in virtualization, basically. And the speed of doing changes to infrastructure is just tremendous. We're able to spin up whole networks with whole systems with a lot of microservices, etc., with just automation. We don't need the hardware at all. I mean, of course, there's going to be hardware somewhere, but we can publish our containers to a container platform and just don't bother about operating systems, etc. So, and that's what this presentation is all about. It's about containers. So, I mean, the revolutions I've been through, there has been some software revolutions as well, and in the previous session was about AI. So, but this is on the hardware side of things, the infrastructure. So the rest of this presentation is going to be a demo. I'm going to walk you through how a Docker file looks, how we can create our own Docker files and create our own custom Docker images. And the Docker files are then used to create containers. We're going to look at how we can build container images from our Docker files. We'll look briefly into the Azure Container Registry, which is basically just any container registry, a place where you can publish container images so that others or yourself can use them. We're going to look a little bit at different techniques for building your own container images, how to keep them as tiny as possible. And then we will containerize an application which contains one web application and a database, just as an example. And mind you, I'm not a C# developer, so if you are and you watch this, don't laugh at my code because it's ugly, but I'm just using it to showcase how you can containerize an application with a database. And then we will look at how we can deploy stuff with Docker Compose to wherever you want, sort of. I'll get to that. So that's the end of the PowerPoint. I'm going to close it. And made changes, so I'll save it. I don't know which changes I made, but we are going to move into Visual Studio. I have created an application. And this application, if we try to run it, just to show what it does and how silly it is, it has a start screen, and I can click on the link state province, and that will give me a list of basically countries. And there is one country called not available, and then we have Sweden, the UK, and the United States. This is the old application. And this is the thing we will work with. So this is the application code, and that application code is this project. It has some pages. It has, I can't even remember where the actual code is, but we have a program.cs where we read in some configuration, and that configuration is going to be reading from this one, launch settings.cs. So there is a connection string, and I'm using the good old AdventureWorks 2014 database, but it's an empty one, so I just filled it with the data you saw on screen. And we have a data source and an initial catalog, etc., etc. We can look at the database project itself. So I'm going to open recent and open the AdventureWorks 2014 DB. And we have, it's just the schema of the AdventureWorks database, but there's a post-deployment script, which basically fills this country region table with some values. So for any target, it's going to use these three. And then if I'm on a server whose name is tsql ws2, then I'm also going to add the not available country, which is on screen. So you see that I'm running against this machine, which is my local machine that I'm working on and presenting from, and it's a good old SQL instance in Windows. And this is not unusual. You have developers, they run their code in IIS Express locally from Visual Studio, and they have a database, and maybe if they're really advanced with databases, they have a database project, and they deploy that database project locally, and when they're ready, they maybe publish it from Visual Studio to a dev environment, or they have a pipeline to do that for them. But one situation is that an application can be a bit more complex than this. Let's say you have this web application is connected to 25 microservices, and you need to deploy them as well, and they all need to be configured to talk to the right database, etc., etc. What we will do basically in this demo is to go from here, from the database instance on Windows, and the application running in IIS Express, and we will try to containerize these two components, and we will publish them first to Docker for Windows, run them locally here, and then we will publish them to Azure Container Instance as a container group with a couple of different techniques. So let's start containerizing the application in itself. And when you do that, you create a container image that contains a base operating system. It's not really a virtual machine that we're talking about. It's just an isolation of a process. So the interesting thing here is going to be the application, the web application. So the container contains the web application and whatever libraries are needed from an operating system to support running the application. And usually, if we go back to the application here again, the state province app, usually when you run it, when you click this IIS Express button, what's going to happen is that there will be a rebuild. And the code is built, and let's see if I don't see the output from the build here, but no issues are found, and I could rebuild it, and there is going to be some binaries, and when you click the IIS Express button, it's going to run those binaries in IIS Express locally on your machine. When you create a container image out of this, it works a bit differently. And I'll show you what. I'm starting VS Code, which is my probably most used tool nowadays. And we're going to look at the application and something called a Docker file for the application. And a Docker file is a description to Docker build, the Docker build command. And the Docker build command is going to look at this and see some instructions. And a Docker file always starts with a from directive. So if you're a SQL person, it's not the from clause, which I often say, I call it a clause, but it's a from directive. And it tells Docker which image are we going to start working with. And if I want to create an image for a .NET Core application, I want to start with a .NET Core image. So I'm going to start with the SDKs, Software Development Kit container for .NET Core 3.1. I know that's old. You should probably use .NET 6, which is the latest long-term support. But I didn't bother upgrading this project to .NET Core 6. I give this base container a name because I'm going to use it later on. I put myself in a work directory in the container, which is called build. This directory doesn't exist, so Docker will create it inside the container. And then I copy the contents of the folder state province app to this work directory, build. And then I run a command. So I do a run directive, and I'm running the .NET command, and I'm doing a .NET restore. And then I'm doing a .NET publish. So these two steps are basically compiling the code for me and releasing the code to a directory called /app. And that's also something that doesn't exist and is created inside the container when I do this. So when this is done, I already have my application compiled and published to the container. But I'm starting with the .NET Core SDK container image, and the SDK contains a lot of build tools for .NET, which I don't need at all. I just need the ASP.NET container image, which is a much smaller than the SDK, and it contains less code that could be exploited from an attacker if they break into my container through my application. I don't want them to be able to do a lot of things. So the ASP.NET, it's just the .NET Core runtime, if you will. And I'm going to call this one final. So what's happening with these first steps is that these are run and a container image is created, but that container image is not ever published to anywhere. No one can use this container image in itself. So I'm starting clean again with a new ASP.NET container image that I call final. I go to a work directory app, and then I copy from my build container image, that's the previous steps, into my app directory. And then I direct Docker so that when someone creates a container from this container image, it's going to start by running the .NET command with the state province app.dll as the parameter. So basically run my web application from the container. So my final container is the ASP.NET runtime or .NET Core runtime 3.1 and my application and an instruction how to start my application. So let's see where I am in my work tree here. I'm going to go to SQL in Azure Containers. I'm going to go to code, and I'm going to go to build this application container. But this is just a Docker file, and we also need to run the Docker build command to actually build it. So that's over here. Docker build. I'm building this directory app. I give it a tag, so basically a name of the image that I'm building, and I'm calling it state province app :11. Then I'm also tagging this existing container image that I have locally with the name of my Azure Container Registry and also a name of the actual application, so that I can, when I push it to my container registry in Azure, I can then later pull this container image and create a container from it. I do a Docker login to my container registry because it's not open for anyone to publish to. And here you have my password. So I'm going to change that after this session. This is not how you should do things, really. If you run this in a pipeline, for example, you should get this from a secrets group in Azure DevOps or from an Azure Key Vault or something. But I'm just running a demo, and I don't really have any secrets in this container registry. So I'm logging in, and then I'm doing a Docker push. So I'm pushing my container image to my Azure Container Registry. So let's run these. Docker build, Docker tag, Docker login, and Docker push. And I already did this before, so it's not going to take terribly long time. What is going to happen though is that since I did the recompile and clean of my application, the Visual Studio solution has changed slightly. So then the step over here, build and restore or publish, are actually going to be run. The other ones, they're not going to be run at all, because Docker already knows that it has these layers of the container image already stored, so it doesn't have to build those layers again. And I think it's kind of nice because you will get an output, which is basically all the steps you have in your Docker file. You will see how long they take, and you will see if they have any errors in them. And then I did a Docker push, and the push gets a response that all the layers already exist in my container registry, so it doesn't really do anything. Cool. It just makes sure that there are no changes to any of the layers inside the image. So that's cool. We have the database project, which also has a Docker file. And I want to be able to incorporate my database into a container image as well. And here I'm going to run on SQL Server 2019. So I'm starting with mcr.microsoft.com, SQL Server : 2019 latest. So that's going to be my source. I'm going to elevate to be root because a SQL Server container doesn't run as root. And I want to do stuff that I need root privileges. So I switch to become root inside the container. I installed a lot of libraries, and the whole reason to install all these libraries is to be able to install SQL package.exe or just SQL package in Linux, because this is a Linux container. I'm going to change the owner of it to MSQL. And then I switch back to work as the user MSQL. In this container, I have some build arguments. So when you build this image, what it's actually going to do is to start with a SQL Server 2019 container and then deploy my database project inside the container. And maybe I want to be able to give the database itself a different name. So then I have DB name as a build argument. I have an SA password as a build argument, and I have the path, the local path to my DAC pack, which is basically the build output from a database project. So I have that as well. And then I want to copy the DAC pack from my local machine to a path in my container. So I'm doing that. I'm setting some environment variables, the SA password, and accept the end user license agreement, so that I don't need to do that when I start a container. Mind you though, since I built this into my container image, that means I am taking blame if anyone else uses my container image without actually knowing anything about the end user license agreement. So maybe I shouldn't put that as an environment variable. Instead, I should have anyone who starts using my container image explicitly accept the end user license agreement. But the way to do it when you build a container is to set an environment variable. So that's what I'm doing here. Then I'm running SQL Server. And when you run a SQL Server in a container, you just run it from the command prompt. It's like running SQL Server.exe on your Windows machine, but not run it as a service. And what you will then get is an output of the error log to your terminal. And I'm doing that, and I'm using the command grep to find output from the error log. And the output is Service Broker Manager has started. And if you ever looked at an error log, this is one of the messages that you get when everything's basically up and running, and you're able to create connections to a SQL Server. But I'm going to sleep for 15 seconds, because what's going to happen after this is actually that the databases, the system databases, are running through some upgrade steps, because I guess the container image is built on the RTM version of SQL Server 2019, and I'm running the latest. So that means many cumulative updates are applied, which means running upgrade steps in the system databases. So I'm sleeping for 15 seconds. And then I'm pretty sure that my SQL Server is ready to accept connections for real. And then I'm running SQL package. And SQL package is the tool you use to deploy a database project or a DAC back to create or deploy a database. I'm running the publish action. I'm running it against localhost because I'm inside a container now. So the local host is the container itself. I'm setting a database name using the build variable. I am accepting that I'm going to trust the server certificate that I get. And I'm going to connect as SA, and I'm going to use the SA password. This is not best practice either, but what you will then do when you create a container from this container image is to change the SA password or just disable the SA account as soon as you get into the machine. So I think it's pretty okay just during the build phase of the container. And I'm gonna tell SQL package that you can find the DAC pack over here. That's the file source. When that's done, I'm going to remove the DAC pack from the container because I don't need it anymore. And then I'm going to run the kill command against the SQL Server process because this is just building the container image. It's not actually running the container. And then after this, whatever is the entry point from the source container, that's what will run after this if I then start the container from this container image. So I have a similar build PowerShell script that runs the build command, so docker build. I'm using the Docker file in my DB directory. I give it a tag. I send in some build arguments, and etc. and etc. And I'm going to run this. That was pretty quick, right? Because nothing happened. This is very strange. Maybe okay, I just ran the selection and I didn't select anything. Okay, let's run it for you. So now it has some cached layers. It is running a layer, which is actually publishing my DAC pack to over here. It's starting SQL Server, and then I had to sleep 15 seconds. So this is going to take a little bit of time. And now it's publishing to localhost, to my Docker container registry on my local machine. Or actually what it's doing, it's publishing the database. Sorry about that. It's a bit boring to watch, but you will see the output from the DAC deploy. It's creating a lot of objects in my database. It's actually creating the database itself. And then it is doing some extra build steps, which I'm not sure I showed you. But let me go back to the Docker file. They're hidden. So going back to the Docker file, I'm doing the same thing that I did with the .NET Core application. I'm doing it what's something called a multi-stage build. So this will be my source for the rest of what's happening in the Docker file. And then I'm starting again with a clean Microsoft SQL Server 2019. I have the same password and database name that I had before. And I'm accepting the EULA and I'm setting the SA password, but I'm copying from my source container, which is the upper part of this Docker file. And I'm copying the data file and the transaction log file to this container image. Yada, yada. And why am I doing that? Well, because if I would just leave the container as it is, create a container from this container image, it's going to be pretty large because it has the unzip, the libunwin, the libicu66, libssl dev, software properties common, and SQL package.exe itself, and a lot of things that I don't really need to run the container with a database in it. So therefore, I'm doing these copy commands down here. And then I switch back to become the user MS SQL, and then I run SQL Server. And inside SQL Server, I'm running SQL CMD, or against the SQL Server. Once it's started, I'm running SQL CMD, and I'm running SP attached DB with the database name and the file names for the data file and the transaction log file that I just copied to the container. And I'm not sure if we can see in Docker. Let's move Docker over here. If I look at my images, I may be able to see the intermediate steps that contains, or we can see that in the layers maybe. Let's see, I have my AdventureWorks 2014 DB. What I'm after is looking at the different sizes here. And you will see, okay, they're not in the final image. Okay, so let's just forget about that. If I would have left it over here and just stopped the Docker file over there, we would have been able to see in Docker for Windows the size difference between what I have now and what I would have had if I didn't do a multi-stage build. And that's a matter of 2-3 gigabytes difference in these containers. And when you start a container, you want it to be fast. When you pull the container from a registry, you want it to be fast, and then size really matters. So what I did show you in both these cases is an example of multi-stage build, where I start with something, I do a lot of things, I install software into the image, but if I don't really need the software for the final product, if you will, then don't keep it. Start clean and just copy the stuff you need over to the final container. So that's the takeaway from that. Now we have a Docker image for our database, and we have a Docker image for our application, and then we are ready to run the application locally. So to run the application locally, I'm going to create a Docker network because I want these two containers to be able to talk to each other. And then I'm running the Docker create command. I give a name of my container. I call it app, very creative name. I send in an environment variable, which is the connection string. And the connection string is going to be data source AW2014. And that just happens to be the name of the other container that I create. And since I put these two into the same Docker network that I call Transmocopter net, and as you can see on the Docker create commands, they all belong to this. Docker will create a third container from me, which is a DNS sidecar container, so that these two containers can talk to each other by name instead of publishing port numbers, etc. I still publish the port number for my database container to the outside world by using the -p command or parameter. And I port 1450 to the local port 1433 inside the container, but that's just so I can make a connection from SSMS into the database. If you don't want to give people the possibility to run direct queries to your database, then just remove this. And the only way to talk to the databases in the container will be through the application, which is how you probably want to have it in production. So let's try this. Docker create and Docker start of these, and run it. Fantastic. I have a network already, so I'm going to remove that network first. Docker network rm transmocopter net. And I can't because I docker stop app, docker stop AW 2014, docker rm app, docker rm AW 2014, and docker network rm transmocopter net. Okay, now we start clean. I run the all these commands again. And now we have, if I inspect with docker ps-a or just docker ps, we see that we have one container called AW2014 and one called app. The one called app I didn't show you, but it's publishing port number 8000, and that's pointing to port 80 inside the container. So at least in theory, we should be able to browse to our application. HTTP, there is no SSL around here, port number 8000. And that's the application. Fantastic. And if I click state province, you see I only have 3 countries. When I ran it from Visual Studio, I had 4, because in my publish profile, or rather in my database project, I'm looking in the post deploy script if I'm on an instance named tsql ws2, and that's when I create the 4th country. But I'm inside the container that doesn't have that name, so therefore we only get 3. And this is just to prove that we're running against our newly built container image. So that's all fine, but we're still running stuff locally, right? And I don't know if we won a lot. We added some complexity with Docker files, etc. And I want to run this on someone else's hardware. And I'm going to choose to run it on Microsoft hardware in Azure. And I'm going to deploy it to Azure Container Instance. There are 2 ways to do that. We could do that with a really ugly YAML, Azure deploy app ACI YAML. And this is a YAML that describes to the Azure Resource Manager how it should create my different stuff in Azure. And I'm just gonna, it looks a little bit like the Docker create commands. It's just that it's ugly YAML instead. We have an image, which is not the local one, but instead it's pulling from my Azure Container Registry. And I set the DNS label, and that's so that I can browse to this container group once I publish it in Azure. And I need to set the port number that I publish it on. And I need to give my image registry credentials. So again, don't save them in a file like this. And you need to give a type, which is for the Azure Resource Manager to understand what it's going to do with this YAML. So it's going to create a container group. Okay. And I have now a published container group PowerShell script, which does AZ login. So using the Azure client, and then does Azure Container Create using this YAML file. And let's see if this works. I need to sign in. Yay, I'm signed in. Cool. Let's go back to VS Code. Web browser has been opened, etc., etc. It's doing the login, and it's inaccessible image. But why? Maybe because I used the wrong password for my. Let's look here if I didn't update the password in that file. It looks like the same, so okay. It's not able to pull the container. Let's not bother about that because this is a very cumbersome way of describing your deployment. It's much, much easier to describe it in a Docker Compose file. So Docker Compose is a way to publish your applications to basically anywhere. As long as it's a target that understands how to talk with the Docker client. So I'm going to start by publishing this locally. So I'm just doing Docker Compose up, and I want it to be detached. And if I have a Docker Compose YAML in the same directory that I'm in, then Docker Compose is going to look into that and see that, okay, it has two services. It's app2 and AW2014-2. It's injecting some environment variables. And now I have the data source AW2014-2 because that's the name of my database container. And I can run this, and I define the network just the same way I did with the Docker network create command. And I set some reservations and limits on my different, basically the whole deployment actually. So let's try this locally first. Yay, it works. And what did I give as the port number? I'm publishing on port 80. So let's try localhost port 80 and see what happens. Yay, my application is up. And that's both the database and the application deployed with just the Docker Compose up. And when I'm done, I've done my tests, I can do Docker Compose down, and that's going to remove all the stuff. So the container app2, container AW2014-2, and my network are all down. So let's see if we're able to publish this to Azure instead. And the way to do it is to switch context for your Docker. So we have Docker context, and I don't remember the name of the context. So I'm doing Docker context list, and I have, which ones do I have? Docker context use Azure, maybe? No. Okay. Docker context use transmocopter ACI. See if that works. And Docker compose up -d. No, you're not logged on to Azure. Docker login Azure. And I'm logging in. Once you do this on a daily basis, you will not make these silly mistakes that I'm doing. So we'll try Docker compose up again. Oh, it's connecting to the wrong subscription. Why is it doing that? Docker context list. It's all very boring to watch me do this, isn't it? Docker context show, transmocopter ACI. Why is it doing this to me? It's not very nice. So the thing is, I have different subscriptions, and I should have noted down how to switch the subscriptions in here. please use the authority URL to get the token. So I must, the access token is from the wrong issuer. Okay. Docker context, use Azure. No, I'm really sorry about this. I'm missing something. This is what happens when you agree to present without having the time to prepare for your presentation. I know there is a step that I need to set in the context to set it to the right subscription, because it's going to the subscription where I don't really have these resources, and I'm not able to access my ACI. Let's try to just switch context, use default, do the Docker login Azure again. And let's see if I'm able to do a Docker compose up to Azure now. No, because it's doing it locally. Docker context use transmocopter ACI. Still the wrong error. I'm really sorry about that. I'm missing something when I do the context switching here. And I could, of course, spend 8 minutes to try to figure it out. Let's see if it's fast. Set the subscription. Do you have any questions? Asks Kai. Yeah, I agree, Kai. People should do evaluations, and they will write, maybe Magnus should prepare better for his demos. Yeah, maybe. I need to set the tenant ID. That's done. No subscriptions found. So I really need to set the tenant ID. Okay. I thought that was done. What is the actual output here? It's just login succeeded. Okay, I'm not going to be able to finish this, which is kind of a pity, because it would have been cool to display that I would, in the Azure portal, have the Azure Container Group over here as an application that was newly deployed and so on. But I'm not going to be able to go all the way with that, unfortunately, for now. So, do you have any questions? And if you don't, I want to thank you for spending the afternoon with me, or morning or evening, depending on where in the world you are.